Here's our problem. You have $3,000 to put in the 24-month CD that yields 4% interest. How much money will you have at the end of the term if it is compounded daily, weekly, monthly, quarterly, semi-annually, and annually? So that's our part 1. So it's A. So pretty much what we do is we use the formula A equals P times 1 plus R over N to the NT. So that'll be A equals 3,000, since that's the starting. 1 plus 0.04, that's the rate, over N, which is the time, 364, since it's daily, there's 365 days in a year. Then that to the power of the N and the T, which T is 24 months, which is 2 years. So we do that and we get 3,249. There's 85 cents for daily one. Then we pretty much do the same for the next one, except we just change the ends, which is now 72 weeks. So put the starting 3,000, 1 plus the rate over 72 weeks, and then to the power of 72 weeks, there's 2 years, and we'll get 3,249 with 79 cents. For the monthly, again the same thing, 3,000 times 1 plus the rate over the, since it's monthly, it's 12 to the power of 12 times 2, since that's 2 years, and we get 3,249 with 43 cents. Then for our next one, same thing, it's quarterly, so we put 4 in the bottom as the end, and pretty much we do the same thing all over again. We get 3,248 with 57 cents. Then for the semi-annually, it's half a year, so 3,000, 1 plus the rate over 2, since it's since half a year, times 2 to the power of 2, and 2 stays the same, so 2 years, so it's 4. So 3,247 with 30 cents will be your answer. Then for the final one, it's annually, 3,000 times 1 plus the rate, interest rate, over 1 times to the power of 1 times 2. So 3,000, we'll get 3,244 with 80 cents. So we're done with our first part. Let me go to our second part. How much money will you have at the end of the term if it is compounded continuously? So continuously, we use a different formula. We use the A equals P times E to the power of RT. So A equals 3,000, since that's our starting. E was just E to the power of the interest rate, which is 0.04, and it's come out 24 months, which is 2 years, so it's 2. So we get that, and we'll just plug it into our calculator, and we'll get $3,249 with 86 cents. Then we're done with our part B. We then go to C. You invested 3,000 into a 24-month CD. What interest rate do you need to look for if you want 5,000 in your account by the end of 2 years? So we use the same one, A equals P times E to the power of RT. So, but instead of putting the A, we already have the A. We'll put 5,000 there, equals 3,000 E to the power of. So we're trying to find the rate, so we leave that blank, R, and we get 24 months, which is 2 years. So we pretty much cancel out using logs. So log, they'll cancel with the E, log 5 over 3, and then we'll left with 2R equals natural log of 5 over 3, which is divided by 2, so we'll get 0.02276, but then we move it 2 decimal places to get our percentage, which is 2.27% interest rate, in order to get $5,000.